5 reasons why your loan application is getting rejected. No, I don't know the reasons, but I can explain how do banks decide whether you'll get loan or not. Generally, today banks are using credit scorecards which are built with historical data using your borrowing history, your income levels, debt levels, and 100 different things including your address. These variables may vary from institution to institution, but the main objective is to improve predictive power of your repayment, and from a statistical point of view that is rational. But here is the structural issue. The data reflects history and history is reflecting inequality. If wealth accumulation is uneven across regions, and if there are limited job opportunities in certain regions, or maybe wealth accumulation differs across regions, then these disparities get embedded into the data sets and then they get reproduced by the model by construction. And that is not by intention, but by the structure of the model. This is precisely the argument put forward in the book Weapons of Mass Destruction. The author is referring to algorithmic systems as WMDs, not in the literal sense of being explosives in nature, but because these systems operate at scale and have the ability to affect millions of lives, and they are opaque in nature, so they are harder to challenge. The core claim is not that mathematics is flawed. It is that when opaque and scalable algorithms are deployed without accountability, they can reinforce structural disadvantage. And there is empirical research present which supports this claim, especially how credit score models have amplified income inequality across various nations. The problem the author is highlighting is not specific to machine learning or artificial intelligence models or the models which are black box in nature. In fact, most of the systems she's referring to are traditional in nature. You could see the variables, they are transparent, but they were still capable of amplifying inequality. That is problem number one. Problem two is newer. Today, the decision systems are far more complex. Earlier, we had credit scorecard models, but today institutions are using machine learning models which are trained on massive data sets. You can see the input, you can see the output, but you will not know what the hell is going on in between. These systems build internal layer of interacting parameters. There are thousands and even millions of weights adjusted to reduce error. The result is often higher in predictable accuracy, but harder to trace what the hell is going on in between. Back in 2008, the vulnerability was overconfidence in one modeling assumption. Today, a potential vulnerability can be overconfidence in predictive precision, especially in those models whose internal structure is far more complex to understand. The common thread here is not a mathematical formula. It is the institutional confidence in mathematical systems whose embedded assumptions are maybe not questioned at the scale at which they operate, and that is the structural parallel.